Business Now is brought to you by Nextel. How business gets done. And now, here's Karen Ryan.
Imagine a world in which tiny sensors positioned everywhere in the environment, even inside our bodies, transmit data that is received in three-dimensional images for scientists to examine. Or a wireless internet that allows us to be connected to anyone, anywhere, anytime. Many scientists say that technology is only a decade away. Business Now's Stephanie Abrams reports.
There are some events most of us would rather study from a distance, like tornadoes, hurricanes, and other natural disasters. But now, a new technology using satellites, sensors, and optical communication systems is enabling scientists and policymakers to go places no one could go before. And this technology will soon be coming to any number of wireless devices near you.
Well, imagine that you're in a world where there are sensors virtually everywhere. There are floods of data of all kinds coming in, chemical data, biological data, structural data. Then there's satellites with their data flows. There are video cameras coming in. How are you going to make any sense other than visually of that? Well, we want to create virtual reality rooms, and we want to optically connect those so that you can actually share experiences in this virtual world. I mean, think of it as online games on steroids. That's what we do.
For example, scientists at the Scripps Institution of Oceanography are using such techniques to study evidence of a terrible earthquake and tsunami that occurred in Lake Tahoe some 40,000 years ago, an event geophysicists say will likely happen again.
There are potential two risks within the Lake Tahoe Basin regarding fault lines. One is just an average magnitude 7 earthquake along either the West Tahoe or State Line Fault could itself generate about a 30-foot tsunami wave. And so what we're trying to do today is use these types of immersive environments to study the structure of the Tahoe Basin to determine when this might happen again.
To understand why such visualizations are so critical to research, consider the difference between a still and moving video.
It's like looking at a picture of the ocean. You don't get a whole lot out of that. Versus going there and being in the ocean, you can then make a real simple relationships between complex data sets to say, you know, look, the surfers are all going from out in. And just looking at a picture, you can't see that.
But to make such a sophisticated optical network run, a new kind of switching device capable of handling enormous volumes of high-speed data was required. TeraBurst, a Sunnyvale, California company, has developed a new optical switch that lies at the heart of the system being tested by Scripps and San Diego State University.
Imagine you've got 10 gigabits, 10 billion bits a second coming through. Well, they're just another 10 billion. Oops, another 10 billion. Oops, another 10 billion. I mean, that's some pretty heavy lifting to take those things and to say, okay, go that way, go there, change color. And so this requires technology that is just like science fiction in a way. And yet TeraBurst is delivering it today.
According to COO Tom Myers, TeraBurst technology is unlike any other optical switching system.
What the switch does is it's able to bring the bandwidth of communications up quite a notch from where it used to be.
Myers isn't the only one who believes TeraBurst has set itself apart from the competition.
We see TeraBurst fitting within the telecom market space of approximately $2 billion in 2005. And the reason why this is so exciting is that this very high-density application, this very, very fast application, utilizing light, utilizing dense wavelength division multiplexing, enables applications that we haven't been able to see before, applications that require an incredible amount of bandwidth, such as the immersion visualization that we've seen TeraBurst enabling.
What excites me is the technology. We're doing some very unusual things that people have not done before, and we're really working towards leading the edge of communications for the future.
A future in which we'll travel inside the body, to the depths of the deepest lakes, to the surface of other planets, all without ever needing to leave home. I'm Stephanie Abrams for Business Now.